All right, this is Chapter 7, Section 3. This is the fourth video. So in the past, we did uniform, normal, and unknown distributions. This will also work for binomial. So if the data is approximately binomial with this number of samples, and p is the success rate, right? It'll actually work for this. Okay, so these are your formulas for mean and standard deviation. So again, remember, if you use something that's not a normal distribution, that's fine, but you still have to calculate the mean and the standard deviation for that deviation to be able to do the normal approximations. Okay, so if I do this is here, this would be 300. I'm sorry, what did I get? Not 300. Sorry. This will be 460 times whatever the case may be, you know what I'm saying? So we'll say 50%. Okay, and this will be the square root of 460 times 0.50, right, times 0.50. You're like, where are you getting those numbers from? Well, we did this problem in prior chapter, right? Chapter 4. So you take 945 couples with one kid. What's the probability you're going to get 460 girls? We're going to assume it's 50% chance to get a girl. It's not actually, it's actually more from mammalians. It's more than 50% chance of getting a female for obvious reasons. So we're going to calculate using Excel manually, which is what we did in Chapter 4. We're going to use the binomial density function, and we're going to use the normal density function. Okay, so obviously the normal one is an estimate. Okay, and we'll figure out why would we do that. Okay, so let's do it with the density function here. So we're going to do factorial 945 divided by the factorial of 460 times the factorial of 945 minus 460, correct? Close parentheses. There's the count part. Then we have 0.5 to the 460, and then we have 0.5 to the 945 minus 460. Okay, and you're like, wait, this isn't working. So you have to do the count times the probability of success times the probability of failure, and it doesn't work, right? And you're like, why doesn't that work? Because remember, if you're doing 945 factorial, that number is so large, right? Okay, that's like more than all the atoms on Earth. Okay, that's a massive, massive number, so it can't do it. So we have to try to use the density function. So I'm going to try to use the density function. So I use the density function. I'm going to do binomial distribution. That's 460, comma, 945, comma, 0.50, comma, false. And you're like, why is it false? So 460 is what I want to know. 945 is the total in the number of trials, right? Trials. Probability is 50% success. And false, because otherwise this will be 0 to 460, which is not what I want. I want exactly 460, so do false, which means don't add it up, don't accumulate. So I'm going to get that answer there. Versus, okay, normal dot distribution. Okay, I'm going to get 460, comma, the mean is 945 times 0.50, comma, the square root of 945 times 50% times 50%, right? Comma, false, right? So if you look at this, this is the mean and the standard deviation we had calculated before at the top of the page, correct? And again, I put false, because again, this would be 460. This would be less than 460 if I did this, correct? But I don't want less than 460. I want exactly 460, so I did false. Okay? And I get this. okay, which is pretty close to an answer, right? So this fails pretty quickly because the factorials fail when you manually do it like we did in Chapter 4. This will eventually also fail, but not as fast. And if both of these fail, the best way to do it is a normal distribution, and that'll be pretty close, within 4 or 5 decimal places as an estimation. So you can use the normal density function to approximate the binomial, essentially. Okay, so let's talk about comparison here. So essentially, in the past we only did true basically in the computer. Now we're doing false because we don't want to add up cumulatively. We just want to do that specific value, right? So we did false. And the answers are pretty close. Whether you estimate, because this is an estimation, right? And this would be the exact. And then this way is the manual way of doing it, but will fail because of the factorials, essentially. Okay? So this is how we're tying in chapters 4 all the way till now, essentially, with the binomial. All right, if we're going to use the normal distribution to estimate these, the problem is we have to use a continuity correction factor. You're like, why is that? Well, assuming you can't have a half a kid, right? You can have 1 kid, 2 kids, 3 kids, so on and so forth, right? That is a discrete one. But the problem is the normal distribution is continuous. So in order to convert a normal to a discrete, right? So you want to go from a continuous to a discrete, right? So this is a discrete model, and this is a continuous function. You have to use a correction factor of 0.5 to include the actual value. Because the problem is, when you do, right, let's say we're doing 460 here, when you're doing the normal distribution cumulatively, okay, it adds up all the area. But if you know anything about calculus, it doesn't actually include this 460. It's only doing less than 460. So I would have to do a correction factor of 460.5 to make sure that actually includes the 460. So you only need to do the continuity correction factor if you're using the normal distribution to estimate a discrete distribution like a binomial, because of the fact that calculus doesn't include the value you're actually calculating. Okay, so let's try some questions here. So let's say I want at least 150. So if I do this and I do 150, okay, if I do the binomial one, okay, the binomial function does include the 150. So if I do this, right, the problem is, let's go to this. Let's do the binomial one first, right? So if I do this and I do binomial dot distribution, right, and I do 150, comma, number of trials is 300, and it's going to be 0.53, comma, true. Okay, that's not the answer I want. Right? Let's go back and read this real quick. So a certain certain school district, which kindergarten through 12th grade, 53% of the population favor a charter school for grades kindergarten through 5. A simple random sample of 300 people is a sample size, or surveyed. Solve each of the following using the binomial and the normal distribution, right? So obviously you either favor or you don't favor. You can't be in between here, right? It's either a yes or no question. Okay, here's the problem. The question says at least 150, right? So if I do this function here, come on, 150, right? That's calculating this with the 150. Okay? If I say at least 150, I want to go the other way. I want this way, don't I? Right? So I have to do 1 minus. That's still not right. Okay, here's the problem. Calculate 150. I want this over here. Okay? I did the 150. The problem is when I type in the 150, it includes this. I want this 150 to go this way. So what I need to do is 149 to get it to work. So when this question says at least 150, Okay, this is what I'm doing. All right, so 150 or more is over here, and then 149 is here. Okay, I'm taking away 149 or less, which leaves me with 150 or more. Because this is binomial, there is nothing between 149 and 150. Because this is not doing a normal curve, right? This is doing the binomial distribution. It's not doing a normal curve. So if you're picturing this in your head, you're wrong. Because it's 148, 149, 150, 151. This is not the correct picture. It's not a normal distribution, it's binomial. So I took away the 149 or less, which leave me with 151 or more, correct? That's essentially what I did. Okay. However, with a normal estimation, this is going to be a little bit different. Okay. So what I want to do here is 1 minus normal dot distribution, 150, comma, 300 times 0.53, so that's the mean, and then square root of 300 times 0.53 times 0.47, right, comma true. And that is wrong. See how far off those are? That's wrong. Let's figure out why here. So the difference between binomial and the normal is the binomial is just doing counts, right? 149, 150, 151. There is no curve to think about. Here, if I do 150, so this function here is doing all of this. The function does not include the 150. Okay? But I need to include the 150, right? So I'm going to put 149.5. Okay, so when I do 1 minus and it flips to the other side, right? Because 1 minus flips to the other side, that'll include the 150 because I subtracted out everything that's 149 or less essentially. See that? Everything 149 or less is now gone. Okay? All right. So 149.5. There we go. So that's pretty close. All right, next one. Okay. All right, so this is our binomial distribution here, right? I think I did that wrong. Yeah, this should be 300. And this should be 0.53. That's what it should be. Sorry. Okay. So probability at most 160 favor the charter school. Okay. So binomial dot distribution 160, right? Comma 300, comma 0.53, comma true. You're like, wait a minute, what about the adjustment? Well, if you think about it here, 159, 160, 161. This function, if I say 160 or less, that's a 160 or less, it includes 160. This function that we do, the density function, right, includes the value you typed in. Okay, so this is saying 160 or less, but it includes 160, right? So that's fine. However, normal dot distribution, if I do 160, comma 300 times 0.53, comma the square root of 300 times 0.53 times 0.47, comma true. I don't get a good answer because this normal distribution does not include the 160. Okay, so if I do a picture here, right, I want a 160 or less, right, 160 or less, but the calculus integral, when I do that, does not include the 160. So I need the continuity correction factor of 160.5. So therefore, when I do it, it'll actually include the 160. Okay, so 160.5. So, long story short, sometimes the binomial requires a manipulation right, by plus or minus 1. Sometimes it doesn't. The normal distribution always does if you're estimating a discrete distribution, essentially. Okay? So in this case, we did not do it for the binomial, but we did do it for the normal, essentially. Okay? All right, let's say we have one of the probability that more than 155 favor a charter school. Okay, so more than 155 favor the charter school. So this is different than before. So if we say 155, right, we want more than that. But this question said more than 155. So that does not include the value of 155, right? So I have to do equals 1 minus binomial dot distribution 155 comma 300 comma 0.53 comma true. So I don't actually need to do a manipulation this time because of the fact 155, this function is going to include the 155 in all this area here. So if I do 1 minus, it's going to flip it to the other side. Because it said more than 155, that does not include 155. So I don't actually need to manipulate it in this case. Okay, so if I do this one, I do 1 minus normal dot distribution 155 comma 300 times 0.53 times, square root of 300 times 0.53 times 0.47 comma true. You will get the wrong answer, right? That's off. That's clearly not correct because of the 155, right? So if I do this, right, I need this area over here, and this is 155, right? I need to include that, correct? So the question is, which way do I go? So I want to go to here, to 155.5. So the area I'm subtracting out is over here, and if I do 1 minus, it's going to flip me over to here, which is it will include that essentially, right? So I want to make sure I do 5 to include the 155 when I go that way. So 155.5. Now I get a pretty close answer. Okay, D and E. Let's take a look at those. Okay, so fewer than 147 favor the charter school. Okay, so fewer than 147? Okay. So binomial dot distribution 147 comma 300 comma 0.53 comma true, and this will be the wrong answer. That's the wrong answer. Because again, 146, 147, 148. I want to know fewer than 147, so that's 146 or less, correct? This function includes that value, right? So therefore I need to modify this to 146. So this is less than 147, because again, binomial is a discrete probability. There's no values between 146 and 147. Because again, at the end of the day, this is doing this calculation right here, right? It's doing this calculation right here. It can only calculate in whole values, right? So I need to manipulate this to be fewer than 147 by doing 146, correct? All right, if I do this one, normal dot distribution, 147 comma 300 times 0.53 times, let me get the square root of 300 times 53 times 47 comma true. You'll get the wrong answer, right? Those are clearly way off, right? Because I want less than 147, correct? So if I want less than 147, now I'm talking about the normal curve, 147. I want less than that, so I want to be on this side, 146.5, so that I will not include the 147, right? Because I want to be on that side. So 146.5, okay? And then we get a pretty close answer, right? And you can add more place values if you want there. Okay, last one. Exactly 175. Okay. So binomial dot distribution. So exactly 175, comma 300 trials at 53%, comma false. So do not add up all the values from 0 to 175, which is the way this works. Just give me 75. That's it. A little less than 1%. Okay, versus normal dot distribution. Excuse me. 175, comma 300 times 0.53, comma square root of 300 times 0.53 times 0.47, comma false. Pretty close to the same answer. So again, also false, because I don't want 175 or less than 175, because that's the way this one works. This one is less than 175. This one is 0 to 175. Okay? So false means just give me that value, not the ones that are less than that, which are 0 to 175. This is negative infinity to 175, but not including 175. But false, just give me 175, essentially. Okay? All right. So that is the binomial. So essentially, whoops, let me copy that correctly. What I'm asking you to do is to give me the exact answer with binomial and estimation with the normal distribution, using the continuity correction factor for a variety of different problems. So if it does fail with binomial, which it will, because eventually factorials do fail depending on the device that you're using as to how far it can go, you can always estimate. And you can use normal distribution to estimate a lot of things, assuming the sample size is actually big enough.